Kasım Hocam will make a presentation about virtual reality technology and its equipment. So I think we have a presentation. I'm giving the speech to him.
Good morning, all. It's going to be a very short presentation, actually, and after that, we are going to continue live demo, using the Oculus Quest 2 device. I think I can. It is already shared.
Check. I didn't share.
Okay.
The right side.
So I think you can see my screen right now.
Yep.
Okay, this is Ozajar Kasim. I'm going to talk about the VR equipment actually we are going to use in our project. For those who are not familiar with virtual reality technologies. So virtual reality basically means that like generating creating computer generated environment in which there will be 3D imagery, different 3D, and then people will interact them in a seemingly real or physical way. But for this one, there are multiple types of devices created by different companies. For example, one of them is created by Facebook and Oculus Quest 2, and the other one by Sony, which is PlayStation VR, and Valve Index VR Kit, HTC Vive Pro 2, HP, and HTC Vive Cosmos. Most of them actually are using almost similar technologies, but each has different specs. And for our project, we preferred Oculus Quest 2 because it's lightweight and cheap, and then it's quite popular and compared with the others. So then let's talk about the technology behind this Oculus Quest 2. It is actually called all-in-one VR device. It has one headset and two controllers, and it's totally wireless. And the technology it's using is called inside-out tracking. That means we don't have any external base station. And it has two controllers. And plus, you don't have to use controller. Actually, if you want to use your hands, you can have bare-handed interaction. It's working quite perfect. And actually, they recently released a hand tool, which is using AI technology. So even if your two hands are closing to each other, so there will be no conflict between them. It will perfectly separate them. I think it's less than a month. It's very new technology. And the resolution is quite high per eye, as can be seen in the slides. And then it is using fast switch LCD technology. Then it also can contain speakers. Then it's providing also, I think it's also supporting 3D stereo sound system. So you can feel or you can notice that the sound, the way of sounds, you know the direction of sounds actually in 3D virtual reality environment. The process is using Qualcomm Snapdragon XR2 platform. It's a quite strong device. It's actually an Android device. So we are using 126 gigabyte version, and there are two more versions. And for tracking, we have three different usages. One is seated version. That means you can sit, and then you don't have to worry about, you don't have to move. Then you can interact in virtual reality environment. The other one is standing version. You can just stand, and then you can look around, but you cannot move. There will be a circle. And the other version is called room scale. In room scale, you can freely move a given room. That means you have to before track a room, and then after that, you can freely move around a room. So it has also a guardian technology. If you go out of the grid, predefined grid, then that means it will warn you using the camera attached on the glass. It can go to the XR mode, so it can show you the outside environment. And actually, there could be different technology using deep learning to maybe to detect the animals or humans or moving any kind of objects. So it will be safely, it will provide safety for users because we are actually blind in virtual reality environment. And so then it has some kind of tracking, different types of tracking technologies. It has 4 grayscale cameras. I think in the new version, they will have RGB cameras. And this camera can be used for room orientation and the tracking. It has also inertial measurement unit inside. This is for head orientation and handheld control orientation here. It has a 6 degree of freedom. That means tracking 3 position in X, Y, and Z, and then 3 orientation in X, Y, and Z again. And this is the controller. It has 2 controller again. It can also track your hands, your bare hands. So using these RGB cameras, sorry, grayscale cameras. I want to show you a brief demo, which is created by Oculus itself. There's no sound in this video. So as can be seen. So this is image sensors inside. And then constellation LEDs in handheld controllers. Plus image sensors for orientation. Okay, that's all.
Constellation sensors are used to detect the position of the
yes, the device, and image is for orientation.
Yeah.
Exactly. Yeah. This is done. I think we can start with the live demo.
Yes, but firstly we connect the
Okay.
device from the.
Okay, let's tell them how to connect the device to the machine. Okay, you can help us maybe. I think we are already shared on screen. So we have to first have Oculus application in our PC. This is
you must
necessary.
install it first.
And then in these devices, you have to add headsets. So actually you can have link cable, which is a USB 3 to Type C. So you can externally buy it, and you have to plug in to your PC. So let's just plug in here.
It has a USB connection.
Yeah, USB. We preferred 5-meter version because it's long enough. And then now we can click add headset.
Firstly, in device, you can open the Airlink connection.
And then you have to open up developer mode.
In experimental menu, I think.
We cannot show it right now, but
Yeah.
there will be a menu. If you wear your headset, you're going to see the menu, and then the menu there will be experimental settings. Inside the experimental setting, there will be
open
Airlink mode. Yes.
When the device connect the computer, there are some kind of
Notification.
Yes.
They say allow your PC to connect the device.
Yes, of course.
So accept it, please. Now it will see the device. Now I think we can use add headset.
Yes.
So now it will ask you which kind of device you want to add. So we are going to choose Cast 2, then continue. Now it will tell you which way you want to connect. We are going to use link cable.
Yes.
Because we have a cable here. Or if you don't want to use cable, you can use Airlink wireless version, but this is faster. And then continue. So now it will start recognizing your headset and then connect it. Sometimes there will be some problems. Hopefully we will not have right now, but we mostly face this problem. If you face this problem, please keep try. There's no proper solution. There's no proper solution for this, unfortunately, because you should try many times.
It's not so stable now.
This is
Perhaps.
the original cable.
Yes, it's original cable. Even if you use original cable, you may face this problem. You may encounter this problem. Since Oculus Quest 2 is not so stable, their software is now so stable up to now because it's
Okay, so
new technology.
So we can try again. Plug up and then plug in.
Katılmak istiyorum.
Then accept it. So, and did you get notification, Yusuf?
Yes.
Then, yeah, this is happening all the time. You should keep trying. Just go back.
Or
Then,
we can try wireless.
okay, let's try this one.
Yes, but firstly, you can share the hotspot, share the internet.
Okay, so in order to access, you have to connect your device and the PC in the same network. For us, we can share our internet, so we can use mobile hotspot. Now we will connect to the same network.
Yes, I am inside.
Okay, now you see it's there, it's working. Guest2 and touch, it's now ready. So you can see your status of connection and then battery on the other things. Now the next thing is,
Yes.
okay, you see the left touch and right touch all can be seen.
She's sending to both of them.
So do you want me run a Unity project or?
Yes, can you open the Unity?
Okay, so now if we have the project we created before, which actually we already have our project, we can try it. So this is our project, so VRarch test, which we already put in GitHub. Then we can directly connect, but before this, we have to install some libraries in Unity. One is Unity, Oculus integration.
Yes, an Oculus plugin framework or something like that.
What is it about? This is it.
Sorry?
What is it about this talk?
This program?
Yeah.
It's talking about.
Oh, sorry.
This taking some times. So the Unity version we are using is 2020 3.3, and since we are going to use Microsoft MRTK tool, and it requires 2020 3.3. So this is a scene, actually, it's our main scene. You want me to start, Yusuf?
Yes.
So, and here you can see that we have Oculus integration. If you don't have this one, you can just simply go Asset Store and click the search online and write Oculus. And then you will have this Oculus integration toolkit. And then since we already imported, we're not going to do it again, but you can say add to my assets, and then it will direct you to the Unity game engine, and you can import all the assets like codes, graphics, models, and everything else, and including some sample scenes. So, and then now we can start, I think, with some demos. This is called Unity Play Mode. Yes, we will make it. Now, actually, you can see the player view. The Yusuf is wearing a headset. This is what he can see. It's appear here. It's clicking something on menu. Maybe we can make it bigger in the C mode here. So he's now choosing one scene.
So one of the building model we developed.
For example, Safranbolu. Yeah. So now I think now you can see the avatar. I want to show you in different views. This is his view. So click game. Okay, now you can see you can teleport inside. Then he can grab some interaction tools such as maybe
go back to the interaction side. Yusuf. So now one of them
we have measure, for example, measuring
tape. Closer.
Yeah, here we have tape. This is actually for multiple users. Multiple users can connect at the same time. So one can pick one side and the other can pick the other side, so they can measure together, maybe window size or door size, whatever they want. So to support multiple users, we use Photon Network. And then to visualize the users to avatars, we use Meta SDK, Meta Avatar SDK, which is recently released by Facebook. Not Facebook, actually, we can call Meta company. So there are other interaction tools, but I think for now, maybe this is this enough? Or we can just continue?
I think it's enough.
Okay, this is enough. So if you have any question, please let us know. Thank you for listening. Want to stop sharing or just?
You can stop sharing. Is there any question?
And John, just one stupid question, Yasin. I mean, there are so many different handsets and different type of gadgets and so on. Is there any consistency over their functions and whether they are adaptable to each other? I mean, the simplest thing that I can give you as an example is look, mobile phones. Yeah, everyone has its own charger, and they are not adaptable to each other. So when I do, for example, now we are 3 partners. Yeah, so the Italy, Turkey, and UK, and we may have picked up different devices. Are they adaptable to each other?
Oh,
So
that's a good question.
what is the consistency over this? Is it possible to have a kind of consistency? Because now this is becoming more common, and also maybe it may be used in the workplaces, you know, the other places. So are we going to have a problem? How we make it easy for us, for everyone?
It's actually a good question. Yes, you are right. Actually, we are using Unity Game Engine. Even if they are using different platforms, we can still deploy our application to different platforms. For example, one is using iOS, no problem. We can export our project to iOS. One could use WebGL, then we can export, deploy to WebGL. But mostly are using Android platform, so it won't be a problem. The technology, if the technology they are using, even if it's different, they have their own toolkits. So using these toolkits and then proper platform, I think that won't be a big difference between
Many
them.
of them is supporting Android, right? Many of the handsets,
Yes,
VR devices
HD
supporting Android.
Yes,
So
mostly they are actually Android-based
even
devices.
the device is different brand or different kinds of device.
For example,
since they have Android, they can run together. There will be no consistent problem.
for example, Sony is using PlayStation version, then no problem. We can export to PlayStation. So because Unity has, it's a cross-platform. So you can write your codes in C#, then you can deploy anywhere, like WebGL, iOS, PC, Mac, Linux, Android, and whatever you want. So it won't be a problem because we're going to use one single language, which is C#.
Okay.
But we prefer the Oculus. The reason is because it is the most affordable one and the most popular one. And it has I think for now it's the cutting edge technology in virtual reality devices.
Okay.
This is what we know from the literature.
This is quite interesting. This is also in my presentation. This from a different aspect. Okay, that's good.
Thank you.
Okay, thank you, Kasım Hocam, for your presentation. So you can close the camera.
Yep.
Hüseyin Hocam, you can take the speech and can start your presentation.
Okay,
if you're
so
ready.
we can. I think in the list that you send me, Pınar is the second, but I would be happy to do it second if Pınar is ready, so she may be able to take it over.
Okay.
Pınar, would you like to go for second? If you are ready. She's trying to unmute herself. Pınar, are you hearing me? Let me drop her an email. Okay, there may be a technical issue, but I'll start my
No
presentation.
problem. No problem, Hüseyin Hocam.
Okay,
We have
she's-
5 minutes to start. If you are not ready, we can
Yeah,
wait.
no, I think she's got a technical problem, so she said just 2 minutes. Yeah.
Okay, no problem.
I mean, these devices quite interesting, and I mean, I was looking at different aspects, but I mean, let me just start, and then Pınar join us later, because yeah, we'll save time. Oh, okay, she's here.
Yes.
Okay.
Just share the screen. Explain that.
Okay, so let me just share my screen, and then okay, I'm sure. Can you see my screen? Can everybody hear?
Yes, we can see your
Okay.
screen.
Okay, so I think I'm going to continue where I left last time. There has been a debate in that area. So artificial intelligence has been seen like a Superman. On the other hand, the others see in a different way. But whatever you do with your gadgets, whatever you do with your data analysis or data collection and so on, there is a green aspect of this. There is the energy consumption. It brings value, but also it costs us in a different way. So then I started thinking about the energy usage of artificial intelligence in line with all other green agenda in the world because of this climate change, carbon footprint, and also if you had a look at the summit that took place in Glasgow last summer. This is COP, and this is where they started looking into to see how they may be able to save the energy and so on. So Innovation UK's UK Innovation Strategy was published in July 2021, and also UK's AI related activities was summarized last summer in August, and how AI driven companies and products have started making impact in that area. Innovate UK is like a funding agency that funds industry-linked projects, and this is a very interesting report about the AI-related activities. When you look at the UK side, for example, London has been claimed to be a city with the largest number of small companies or startups in AI. So this is quite interesting, and it started giving some kind of value. And then a few months ago, in September and October last year, National AI Strategy was published. Actually, it was revisited, revised, and expanded, because there was an AI strategy last time. And then also following that strategy and also data strategy, they published a quite interesting one in relation to defense, because they say, okay, in defense, why we are not using or harnessing data for defense-related activities, from satellite data to sensor data and also image data and so on. Then finally, this came back in October after the defense data strategy, net zero strategy. To me, it was quite late, in fact, because the European Union published this green agenda, green strategy back in 2019. So the UK's one came about 2 years after that. This is all about how you can use renewable energy, how would you be able to contribute towards the carbon free reduction, gas emission, and also how you can make your world, your spaces greener. And this is where they introduce green industrial revolution. So there was in fourth industrial revolution. So the fourth industrial revolution is all about digital transformation and getting the world smarter. Whereas in net zero strategy, they say, okay, being smart is no longer enough, even dangerous, but being green is more important. So therefore, you really need to make your products greener. So now, just over 5-6 years, we transformed from digital transformation, fourth industrial revolution, to green industrial revolution, and this is what they call net zero strategy. So what they are talking about there, look, whatever you do, you need to make it greener. You need to make it use less energy, and so on. And this is where they started talking about green computing as well, green digital tools as well. So, and that's why then we started thinking about, there are algorithms, there are data centers, there are artificial intelligence tools. They keep using energy. For example, if you look at your mobile devices, so all the apps use some kind of AI tool. And also, if you look at your mobile phone, you need to charge it, and they consume electricity. So I think now our role is not only making things smarter, but also making this greener. I never thought of this smart versus green. So I think this needs to be together. So we need to have a kind of balance in that area. So then we started looking to see what kind of devices use how much energy they consume, what kind of energy. If you look at, for example, your smartphone, you can see their energy usage. This is not an old data. For example, if you look at your mobile phone, this is 117 megawatt in total over a year, and also light bulb and laptop, your smart TVs, electric heater, your washing machine, and so on. So what we can see here is that the mixture of daily used devices and daily use equipments in and around your houses. So you can see how much energy they have been using and how much it is costing. So recently, everywhere in the world, the energy prices has gone up significantly. Um, I'm not quite sure how much it was in Italy and Turkey, but in the UK, in April, energy prices gone up by at least 50%. And the other thing is that now people try to reduce the energy usage because now it has become more expensive. Now the government is trying to give money to households to be able to get themselves less affected by this increase. But there are interesting news on the newspapers. People started unplugging the fridges so that they reduce the energy usage, but kids are getting poisoned because of this infected foods, because the fridges are not working. It's a real news. It was on the news recently. It's quite interesting because of some other devices that they consume a lot of energy and they push the energy prices up significantly. And one of them is actually cryptocurrency. The cryptocurrencies energy usage has been tripled, increased by 10 folds, 20 folds, and so on. So the figure on the right hand side, actually, this is a general average energy usage for creating a cryptocurrency, Bitcoin. You can see the minimum, maximum energy usage in gigawatts. It's massive. So not only small devices, but also some other services that have been consuming a lot of energy. And Bitcoin is another one because this is where they also use some kind of a small component of AI and so on. And also smartphones, they use all the apps, and some of these apps are based on the algorithms, AI driven or machine learning driven algorithms, because they monitor you. And also, this is also linked to, for example, 4G and potentially 5G communication systems, and also they consume energy as well, because with this one you have increased your data generation, and this is passed on to data centers, and data centers are working really hard to be able to accommodate this type of data. Okay, so over the last 4 days and this morning, we started seeing VR tools and so on. Do you know how much energy they use? Have you had a look at it at all? Is there any information
Sorry.
about
Sorry.
yeah?
You mean the devices? Sorry.
Yes, the devices. So for
I-
example, when you purchase this, did you look at the prospect to see how much energy
check.
they have been using?
We can check the.
I think it's like a smartphone, just like a smartphone, but we didn't check it actually, unfortunately.
Oh, okay. No. I mean,
But not,
who-
not so
who-
much. Not
yeah.
so much. Like a smartphone.
Just like a smartphone, yeah.
Okay.
Or a smartphone, yeah.
I mean, who checks how much energy our mobile phone uses? We charge it and use it,
Yeah.
and recharge it, use it all the time. It is a very recent article published in February, just 3-4 months ago. Okay, you mentioned Oculus. So this is the 3 watts of power per hour. So this is the least one, yeah. And this is quite good. So it means that you are contributing towards a climate change environment. Thank you so much. So The other one, the HTC Vive, so 16 watts of power per hour, and also PlayStation, it's massive. So compared to Oculus, 4 times more even. So this is quite interesting. So can you see the range of devices and range of functionalities, but also the amount of energy they consume when you use it. So I think this is particularly important. Now when I for example, I used to teach a lot, so unfortunately, because of the management, I don't teach that much. But whenever I go to the seminars and so on with the students, I try to give 2 different aspects. Yeah, so technology is there, technology needs to be there, but also you need to think of environment. Now, in my research, now I started focusing on how I may be able to reduce the energy usage for my data analytics and AI-driven tools. And now we started, for example, simplifying deep learning architectures. In one project that we did last year, for example, we trained a deep learning algorithm, and and also we fine-tuned, and now we reduced the number of parameters in the system by 80%. So we get rid of 80% of the parameters. We just use 20%, and the accuracy was very similar. And we didn't sacrifice the accuracy that much. It means that there is a way of dealing with it. And because if you embed it into a mobile device, it means that it would be able to use 4 times less energy. This is particularly important. When we come to the news, actually, if you look at the Economist, now they started talking about the cost of training machines. This is particularly important, and this is increasing significantly. This is about 2-year article, so it says it doubles every 2 years. Even we started to talk about this in the newspapers, in the Economist, for example. So in another article, so they talk about, for example, AI and climate change. So there's a mixed impact of machine learning algorithms. Yeah, it can help the environment, but also it can hurt the environment because it costs us a lot in terms of the climate change and so on because of the usage of energy. And also the other one is energy consumption of AI poses environment problems because of the data centers. If you look at the data centers, these are the ones that use a lot of energy. That's why the data centers are being developed and deployed in cold places like Iceland and so on. I'm not quite sure where the data centers are in Italy, or if you know anything about it, but there are a few in Turkey. I know where they are. I think there is one in Istanbul. The other one is in Ankara and around, and I think the east side, I think in Erzurum and so on. So they started putting this in different locations. So that, and the other thing is that, for example, Microsoft started using undersea data centers because of the massive usage of electricity for cooling these data centers down. Otherwise, it is very difficult. And also AI carbon footprint. Now, carbon footprint is calculated for your flights, for your cars, for your travels, and so on. Now they also started calculating the carbon footprint for AI training, machine learning algorithms for training and usage, because it's a massive area. And now, probably in the future, now the regulation is coming in to be able to regulate this AI market because of the transparency and so on. So another parameter will be the the value of AI's carbon footprint. So if it is too much, it means that if your model is too big, then you can't use AI, because people try to use an AI with the least carbon footprint. So what is the component of artificial intelligence? What makes artificial intelligence work in mobile devices and other places? So the first one is code. So you write a code, yeah? Which programming language do you use, colleagues?
C#.
We're using C#, Python.
Python, okay. Is there anything else? C#, Python,
Java,
Java, okay. Another one?
C,
C, yeah,
C++, sometimes, yeah.
okay. Okay,
That's-
that's fine. I think that's enough. There are different types of coding, programming languages, variety. That's really good. So what's another component of AI? It's data. Yeah.
Yeah.
So that's why I call myself data generator first. So I generate data. So everyone generates data, and now the VR tools and also metaverse, the companies like banks, and also our mobile devices and sensors, they keep generating data. They're passing data onto different platforms, data centers, and so on. And also, what is another component? It's the equation. Yeah. So the equations in our code make artificial intelligence work. They make a calculation, and then they can produce a result, and it makes a decision. So if you look at all these, each component has its own energy usage. Let me start with the coding programming languages. So there are different programming language, as we mentioned, and actually, when you look at their efficiency, we can look at from three different angles. One is energy consumption, the other one is time that it takes to execute, and also the amount of space they use. Yeah, because if the space they occupy is too big, how would you be able to put into your small device, like your mobile phone? And if time is going to take long time to execute, then then it is not efficient. And another one is energy. If it uses too much energy, your battery charge will be consumed straight away. So because if you look at some apps use a lot of energy, and therefore your charge is getting down and down very quickly. So sometimes they say, okay, don't use that app, or use it when you need it, and at the other time, don't use it and just kill it. So they are all based on the coding, yeah, different programming languages. There are friendly programming languages, and also there are not friendly programming languages. So you mentioned C. This is the most environmental friendly programming language. Thank you so much for using it. And also another one, C++. That's really good. But unfortunately, if you look at Python, Python is the second most energy consumer in terms of programming languages. So Python is very common, especially in data domain, AI domain. There are so many libraries, but this is the second most environmentally bad programming language. So we really need to be very careful about it. So also in terms of the time it takes to get these executed. So again, Python is the second one, the worst second. Whereas if you look at the space that it is going to occupy in our system, is almost in the middle range. Whereas if you look at Java, for example, it occupies a lot of space in your system, in your applications. But if you look at the energy usage, so it is number 5. So it means that it uses less energy. and also it takes time to execute. It's again it's on the top in terms of the less time aspect. So it is a bit difficult to make a decision here to see which combination or which ones would be better to use. But definitely Python is now the most energy consumer, and also it takes long time to execute. This is I think the crucial one. So I think in the near future, I guess Python is likely to be replaced with some other more friendly programming environment. So if you look at the way that is combined together and which combination would be really good with respect to time and memory, energy and time, energy and memory, and also energy, time, and memory. So if you look at the time and memory aspect, I think the best ones is C, Pascal, and Go. But what you can hear is that in this case, Python is one of the last options here. Yeah. If you look at energy and time, you can see that Python is not here. Whereas Python is very, very popular. If you go to different libraries, in AI and machine learning libraries, Python is the top language. You mentioned C++, C sharp. So C sharp is one of the language that has been mentioned in both places, and also energy and memory here as well. And also, if you get everything together, unfortunately, Python seems to be one of the last options, last resort for us to use it. So, in fact, I think this needs to be also communicated with the computer science students. This is not only for energy consumption, but also the optimization. For example, there are some optimizers for programming languages to see how they may be able to optimize it to make this more time efficient. But the students are trying to use less number of lines in the coding. So I think when you communicate with the students for optimizer, I think these are quite important parameters to help them understand the importance and necessity of the optimization as well. And programming languages affect this domain very much. So we really need to communicate this message to students at every level. And this, we said the second component is data. So the data usage is increasing, and also electricity usage in data is also increasing. You can compare this with 2018, 2010. But what is good here is that traditional data centers, the usage of traditional data centers is getting down, and cloud one is increasing, and the hyperscale is increasing. The hyperscale is where modern data centers is used. So regardless of the types, they keep using energy, but with the cloud and the hyperscale, they started using less energy. Not everything bad, colleagues, not everything getting worse, but it's even getting better. So with all these technological developments over the 8 years, now we started using less and less energy for our data centers. Although our global storage capacity is increasing in a linear way. For example, if you look at this one over the 8 years, so the global installed storage capacity increased significantly, and data center IP traffic increasing significantly. With the 5G, it is going to be increasing much more, and so on. But the power intensity, workload, and energy usage is getting significantly down. So this is the good side. It means that especially data side, data aspects, we are getting more environmental friendly. And now we said the third component is the equations. For example, if you look at deep learning, or if you look at simple artificial neural networks, there are equations and they need to be executed, multiply, sum, whatever, and they consume energy when you execute. But when you look at deep learning architecture, it's massive, yeah, massive equations, millions, billions, and so on. So you can see that over the last 10 years, you can see the exponential increase here in terms of the energy usage in deep learning architectures. So what? Because in artificial neural networks, you need to use. There are two different places where energy consumption is. So the first place is the training aspect. Training takes a long time to be able to get the optimum architecture equations. And the second place is that when you deploy, uh, uh, so this is where they use the electricity, for example, a mobile app. Yeah. So this is the finalized version of an artificial neural networks. It means that when you deploy, it means that you had your optimized artificial neural network algorithm, and you are ready to use this product. So at that point, it also consumes a lot of energy. If the model is complex, millions, billions parameters to be calculated and multiplied, so they use energy as well. So you can see that this is a massive increase over the last few years, and this is increasing. So we really need to be careful about it. How we really need to make sure that we reduce that energy usage. So you may be very happy that you got your deep learning architecture up and running, but this is the cost of usage of electricity. Uh, uh, have you heard of GPT-3 or GPT-2 from the Microsoft?
No, I haven't heard about
No.
it. No.
Okay, this is actually like a human. So they talk. So they use different platforms to train it. I'm sure. I think a deep fake, or so they use people to talk different things, although they didn't say. But GPT-3 is becoming very much like a human, and it can learn by itself and then speaks and then acts upon some questions and so on in a very natural way. And this system has billions of parameters. So actually, there was a news about it, and also there was an article about it. So the data used to train GPT-3 is massive. So billions of data points used from different type of sources. For example, they use Wikipedia. So 3 billion points used, data points used to train it. And also numbers of books. You can see that 12 billion, 55 billion, and so on. So can you see the massive data used to train it? Even deploying or feeding data that takes a long time, and also it consumes a lot of energy. And also, if you look at the complexity behind that system or human-like model, it has about 200 billion parameters. So 200 billion parameters need to be calculated, multiplied, and so on. It's a massive. And then they started talking about the carbon emission of that model. So can you see that how much energy a human being is consuming while talking, doing the things? Whereas if you look at that machine, it's like a near human in terms of some activities, at least. So can you see that the energy usage is and the parameter it was required to make it work? It's a massive. So it's a very important component, actually, the amount of energy that was used to run that a model, it's almost equivalent to an average American adult adults usage electricity in 2 years. So, and when you compare the electricity usage, they are using much more energy than a human being. So I think this is something that needs to be considered very carefully. So that's all from my side. I think while we are using the gadgets, digital devices, and also AI data and some other algorithms, and also while coding, I think this is something that we really need to consider for the way future. Okay, that's all from my side. Thank you very much.
Thank you so much. Thank you so much.
Thank you, Hüseyin Hocam. You really evaluate the subject from the different perspective. It was very informative from my side. Is there any question? Kasım
I
Hocam?
have one single question actually in table 5. Can you show this your screen, please?
Yeah, sure, of course, yeah.
You talk about the language consumption, energy consumption. I agree with you totally, but we can see that clearly C is better than the others in terms of speed and the time and energy. But C is hard to develop things.
Yes.
And for me, Python
Is
is
it-
easier. What about this?
Is it the table that you want to see?
Yeah, table 5, exactly. No, I think the table, this one, yeah.
Okay.
So because we need the time to learn a language, and in C there are you cannot find so many library which is written by the others. And
Yeah.
since the data scientists are not all computer scientists, they're
Yeah.
using Python. But Python has so many useful libraries. So they have to learn everything in C and then implement them. It will take longer to learn.
Yeah, absolutely. I mean, there's a reason behind C. You know, as a computer scientist, it's like a machine-based programming languages. I mean, to me, the landscape, programming landscape, or landscape for the programming languages will change over the next few years, definitely. With this energy consumption and with this the massive increased number of apps and also digital gadgets, we can't cope with that number and also energy usage. So I think the programming language, I think we will start seeing either optimized programming languages like Python, or we will start seeing a different languages coming up in the near future. Otherwise, because I agree with you, I mean, C is not easy. And if you look at Python, it's like a plug and play.
Exactly.
Whereas when you look at C, it is not that much. You need to put a lot of effort to learn it and to code it. It is not that much programmer friendly. So and also the governments are trying to encourage everyone to learn programming languages. For example, in my earlier presentation, I mentioned Institute of Coding. So everyone should start learning data analytics, data science, and also programming languages and so on. So C is not an option, definitely. So I think we need to separate this here. If you are a higher level of developer, where you develop programs that consume a lot of energy, I think this is where we may be able to use C. And then we need to start thinking about how C may be easily deployed on other devices. Where the other side of this, how we may be able to make Python like a C programming language, so that they can start using less energy, less space, and so on. I think this is something that software architectures should work on and then deal with it. In fact, there are some other things coming out in terms of the algorithmic side. For example, one of my collaborators in Spain is now, we are working on spike neural network. Spike neural network uses much less energy. compared to deep learning architecture. But the drawback of this is what we picked up, is that this accuracy is much less than deep learning architecture. So is it accuracy your problem, or is it the energy usage? But my problem here is that accuracy. I need to develop the most optimized algorithm. So therefore, my preference, I prefer deep learning architecture, but on the other hand, I need to use less energy. So we are trying to balance it. So we are trying to use hybrid system to make it happen. Otherwise, we can't go anywhere. Yeah, I agree with you.
Actually,
Okay.
Python has a static code. One must break this.
Yeah.
Yeah, thank you so much.
Okay, good. So we'll hand it over to Pınar then.
Yes.
Hello, hi everybody.
Hi.
Good morning.
Good morning. I'm gonna share my screen now. Just to confirm, can you see it?
Yes, we
yes.
can.
Great, thank you. So hello again, this is Pinar from Birmingham City University. Today I will talk about skylighting for graphics applications. To give an overview before beginning it, I will give an introduction, and then since we are going to talk about light sources, I would like to briefly mention about what is light transport in graphics and why we are going to talk about light sources. And I would like to give two novel methods that I worked on for skylighting in graphics. So to begin with, why does it matter to use accurate sky models? Cannot we just add some sky appearance to the sky? Firstly, what we see all depends on the light source. If no light, we cannot see anything. And if there is light, as in this example, what we see change depend on the light source. On a sunny day, what we see is very bright, shiny day, and the cloudy day is a bit more diffuse and the dark. So how we perceive the scenes also depends on the light source. And in graphics, we use this a lot. There are many applications that we can see the light sources are used. It doesn't matter if it is indoor, as in the first example, or in outdoor, illuminating our outdoor objects, or in animations, creating our own creatures. For them to look realistic, to get the details, we need an accurate light source.
Sorry for interrupting. Are you changing slides because we cannot see them?
Oh, really? I'm changing.
Oh.
Sorry. Thanks for warning. Let me share again, maybe. Okay, I'm gonna try again. Okay, I think it's working in this area. I'm so
Yes,
sorry.
it's working.
Sorry for that. Okay, now. So I mentioned through the topics, then I went through an introduction and showed an example of sky models. But I said, why does it matter if the skylighting is right? And talked about the sunny and cloudy day, the difference between them. And I was also mentioning where we use them, how we apply them to graphics. So I mentioned about indoor scenes, like IKEA is using this, or to virtualize our products, a kind of car we need skylighting again for outdoors, or animations for our creatures in movies. We use this a lot. So at this point, the skylighting matters and the create model matters because what we see will depend on the light source to get the details for our images. So at this point, in theory, how does it work? Okay, in reality, we know that we see the scenes with the light sources, but what if in the theory? In theory, in graphics, we use light transport equations to create images. These equations, there are two equations mainly, one rendering and the other is radiative transfer equation. In these two, we formulate the interaction of the light with the surfaces inside the scene. Rendering equation is explaining this. Here, as you can see, light, if there is no light source, we won't be able to get anything, again, as in real world. And in the radiative transfer equation, light is not reflected this time, but it is refracted and scattered. So it is scattered. Again, what in this formula, we again need the light source to be able to see our environment. And these two are involved in creating our images in the graphics applications. And as we can see, in both of the case, we need skylighting. And when we say skylighting, we are talking about two types of the skylighting, and today we are going to look into two types of them: clear sky and cloudy skylighting. These are investigated separately in graphics because the way they work or the models are developed, the techniques are developed separately for both of them. In the case of skylighting, clear skylighting, we can use analytic functions or image-based lighting to generate skylighting. In the clear skylighting, analytic functions are a way to represent the light by using mathematical formulas. Within time, to increase the domain that we can generate the skies, like the atmospheric scenarios, the complexity of functions has increased to be able to represent more realistic, more accurate, high fidelity models. But increasing this complexity also comes up with computation. It's not computation efficient this time because it's more expensive to compute them, which graphics community is not happy with. The other technique used for skylighting is to capture the sky. So we are using some environment maps which stores the lighting coming from all directions at a point. To do so, we need to go outside and capture the sky for the positions where the sun appears. So at this point, we would like to make a daylight animation. This becomes a bit difficult because, as you can see in this example, the sun is jumping. And if we would like to do a smooth animation this time, we need to go out and do a more denser capturing. I would like to show this like a denser one. So it will be more time consuming and it's still tiring task. And also the output will still not be what we want because there will be still jumps in. So it won't be like getting a video of the sky. So to overcome these kind of problems, we propose a novel alternative method based on machine learning. Our aim is to provide a computationally efficient method and also doesn't suffer from capturing the skies. In this model, we are proposing using artificial neural networks. Artificial neural networks are shallow networks. It can work with one hidden layer and it can learn any continuous function. This allows us to generate skylighting with less computations and it can generate a wider range of sky scenarios and it doesn't require us to store many images, so memory efficient as well. In this method, we just learn the existing models and represent them with a neural network. It can create different turbidity values, which is the haziness of the sky for different sun positions. So here we can see some examples. Okay, this is not working. Since I'm using Teams, some features are not working. Normally they are working simultaneously. But here on the above, okay, above shows the captured image, which is jump. There are jumps in between them. If you would like to illuminate an animation, daylight animation, it won't look realistic because there are jumps. But the one below is the neural network outcome, which is very smooth. It interpolates the input images and removes the artifacts as well. And in this video, we can see some different surfaces, reflective and diffuse surfaces. Illuminated again with our method. As you can see, we can see the object surfaces very clear, realistic outcomes, and it is a smooth daylight animation. There is no jumps in between them. And it's very memory efficient. We can see a real-time application, a GPU implementation, fast to compute, very convenient for animation purposes. In terms of errors, quantitative results, our method provides a high accuracy, more than 96% accuracy in learning the existing sky models. And here Prism and HOSEC are the analytic sky functions, which are the state of the art, and HOSEC is the most complicated sky models, clear sky model we have. And Egypt and KIDAR ones are the environment maps captured in Egypt. And KIDAR is the one provided by the authors in their study. So our method can learn these are the absolute error differences between the images pixel-wise comparison. As you can see, the difference is quite low. It means that we can use our method instead of them. And in terms of timings, we speed up almost 3 times the existing models. So up to now, we have talked about clear skylighting. In literature as well is focusing mostly about clear skylighting because cloudy skylighting is much more complicated. It's because if we can add some texture our images to look so that our images are looking pretty with the cloud appearance, but this doesn't reflect the reality. In many cases, we need the clouds as a light source, not only as the appearing in the sky, because it's all such a, as in the first example we have seen, all the appearance, the ambience of this scenes are changing. But clouds are computationally not efficient, not easy to use as a light source. It's because it requires to simulate not only the clouds, also the whole atmosphere and the light interacting with the atmosphere. This is quite computationally inefficient, even for offline rendering. It's not only for gaming, let's say. So we can achieve this in 2 ways. Current methods are using on mainly 2 methods. The first one is to capture the sky. We get again our cameras, go out and capture HDR images of the sky. This is not preferred. First, for the skylighting, we need high resolution images. For high resolution images, we need specific cameras, which are costly and expensive. And if we would like to get some special sky scenario, like the sun at a specific position and the cloud with some specific shapes or locations in the sky, it's let's say hard rather than impossible to get in the sky what we want. The other option to deal with is to generate our own models. We can generate a 3D cloud volume, an atmosphere, and do ray tracing, simulate the light transport that we mentioned, the radiative transfer equation that we need to solve. After doing these heavy computations, we can get an image. So this is too complicated, inefficient way of generating images. Mostly the graphics community do not prefer this way. Therefore, we are providing a third option which will not suffer from these. So it doesn't require any 3D cloud volume, because 3D cloud volume generation requires knowing how to generate models. So mostly artists know how to generate it, but still it might not look realistic. And heavy computations, not everyone has access to heavy computations and generate this skylighting. Capturing requires device. So in our option, in this method, we are providing a much simpler way to remove these barriers in the graphics. And how we do this? We are so this is very user friendly. It only requires two inputs. First is a cloud map. Cloud map is a binary mask. It's represented in Fisher format as in the environment maps that we have seen before. What we do with this binary mask, the user draws the cloud shapes that they want on a black canvas, let's say. And this is very simple. This can be generated even with a paint application. And then when this map is ready and the other input given by the user is a sky map. Sky map is like the clear skies that we mentioned. Any sky scenario that we want. Sky scenario means the turbidity, haziness of the sky, and where the sun where we want the sun to be in the sky. So when these two inputs are given, our network, which we call CloudNet, synthesizes these both or encodes them and then decodes them as a cloudy lighting, as you can see on the right here. So given a cloud map, by using the light information, it decodes it into a cloudy lighting. For the CloudNet, what we use as a CloudNet. In this method, we have used UNet structure to encode our lighting. In UNet model, in the first layer or sequential layers, the first part is encoder layer. Here we are encoding the given lighting and the cloud map by lowering the resolution through the sequential layers and generating a low resolution encoding. In the second step, we have the decoder layers, which uses the encoding features that we have estimated and getting the encoded images, low resolution images, sequentially back again, this time increasing the resolution and generating our outcome. Let's have a look what we do with examples. So as I said, this network is not only generating the cloud images, but by looking at the cloud map, it also uses sky map. So this example is emphasizing this. Given two different sky maps with the same cloud map, we can see the clouds are illuminated differently. The lighting on the clouds are changing. So it reflects the light skylighting, the sun position onto the clouds. This is quite important because it means that it can learn the existing sky, clear sky, to generate the clouds. It's not only filling the gaps in the mask. And here we can see 3 split examples. We have split into 3 where we can see the clear skylighting given as an input, our reference model, and the CloudNet output. These examples are again emphasizing that output sky is not just compositing the clouds, as you can see. It is also the reflecting of the skylighting. We can see how smooth is the transition with the reference images. And it also adapts the skylighting to cloud lighting. We can also see how that change appears in these splits. Another example to demonstrate our method. This is juxtaposition. So the images are split from middle into 2. The one on the left showing our reference images, where on the right we can see CloudNet outputs. Again, we can see the illumination across the sky is very consistent with the reference models visually. It can generate very close to reference images and very natural way. Here I would like to also mention that we have seen some realistic images, cloud types that we can see in the skies, but our model method also allows us to generate clouds that we would like to come up with, like some artistic ways. So here we are seeing a dog example and illuminated for different sun directions, and the images are rendered with our cloud lighting. This example also says us that so we can use the generated outcome images class for illuminating the scene. It's not only to give a cloud appearance in the sky, so it's also a light source, and any configuration can be generated with this method. Another thing that we can see here in this example, you can see how the appearance of the scenes are changing. The overall ambience of the scenes are changing when there are clouds in the sky. And in this example, we are demonstrating again how clouds and clear sky has different impacts on our outcomes. The one on the left is with the clear sky, and on the right, it's with cloudy sky. I think this is a good example for England. So it's rarely we see the clear sky lighting as on the left. If you would like to do an advertisement, let's say, in England, I think you should prefer the one on the right, because this is most of the time what we see the clouds in the sky. So we can see how our scenes or images are changing when the clouds are used. So this was all I was going to say about skylighting, and I'm happy to hear if you have any questions about it.
Thank you very much, Dr. Pınar. Is there any question? So can this study be done with CNN, with convolutional neural network, or
In
did
fact,
you use this technique in your studies?
So UNet is in fact a type of CNN. So it uses convolutional layers only structured in UNet, and kind of generative methods like GAN or autoencoders only shaped as UNet. So it's using convolutional layers actually, only shaped in as a U, as you demonstrate. Yes.
Okay, thank you.
So
Thank
can
you.
we say that in the near future, we will see these artificial skybox or sky in some game engines or in some, some modeling application?
I would be very happy to. So this is the aim, in fact. So in game engines right now, it's very limited, this cloudy lighting that they produce. So this is the aim. In fact, the feature work after this is to make it also dynamic, because this is for one sky scenario, but the clouds are moving. By taking this, making it dynamic clause is the aim. If this can be right now adapted as in this, and it would be great to see it being used, because it's much simpler and it gives much more flexibility to the user. And I am hoping with making this dynamic, then I think it will take much attention, hopefully.
It will be very
This is-
nice, actually. We will be happy to use it. Thank you.
Thank you so much. I would be happy that seeing it being used.
Okay, thank you. So with this presentation, we came the end of the our activities. Thank you for your participation. Hüseyin Hocam, we will send your participation certificate on email or on we can send it on email.
Okay. We can send our avatars to get our certificates.
Of course, we will be happy. Yeah, we'll be happy. Please send us.
Okay, thank you so much for making this arrangement.
Okay, it was
Very
very
much appreciated.
fruitful. This meeting was very fruitful from our side. That was very informative presentation. Also, we made some very informative case studies here. I hope we will continue with next meetings in Italy, in England.
Yeah.
So see you there.
Okay, enjoy
Okay.
the rest of the
Nice
day
to
in
meet you.
Turkey. Thank you.
Nice to meet you to us.
Okay.
Have a good day. Bye-bye.
See you. Bye-bye. Bye.
Bye.
Bye. Zaten kapatıyoruz.